Let's look at lesson 35, exterior angles in polygons first. We have a figure here in example 35.1, and it gives us all the different stuff. And it says to find x and y. The way you solve this, you just gotta, once you know this, it's going to be easy to solve. Exterior angles in polygons all add up to be 360. So in this polygon, we have exterior angle here, and so on and so forth. Those are all your exterior angles. All those add up to be 360. So I'm just going to put it in right here. X plus 65 plus 50 plus 40 plus 80 plus x plus 55 equals 360. And I'm just going to put that in my calculator of, well, x plus x is 2x. Then I'm going to add all these numbers in my calculator. I'm going to put in 65 plus 50 plus 40 plus 80 plus 55, and that's 290. Well, sorry, not equals. So now we're here. 2x plus 290 equals 360. So now subtract the 290. Uh, 70 equals 2x, so therefore x is 35. X is 35. Now it wants us to solve for y. Well, you can probably figure that out. They're a linear equation. So so they're supplementary. So x is 35. So 35 plus 55, that's actually 90. So y would be 90. That would mean they are perpendicular. And that's how you solve for exterior angles in polygons. Doing some shapes, looking at some geometry. Let's look at one more shape here. This is known as inscribed quadrilaterals. It's called inscribed because it is inside of the circle. This quadrilateral is. The rule for this is if a quadrilateral is inscribed inside a circle, the sum of opposite angles is 180. So what are my opposite angles here? We have 35 and y. Or sorry, that's a 75. 75 plus y, therefore those equal 180. And we have 80 and x as opposites, therefore those equal 180. Oh, sorry, 80 plus x. And you can solve. I'm just going to do this mentally. Y would be 105. X would be 100. Those are two answers, and that's how you do inscribed quadrilaterals. Opposite angles are, their sum equals 180. Now let's get into kind of a newer concept here, when you haven't done as much before. I want to first start by saying there's two different ways to write square root of 2. Two different ways. You have previously done this one. That is what you have done. But if we write it as 2 to the 1/2 power, that is the same thing. These correlate. So, and that continues on. 2 cube rooted is the same thing as saying 2 to the 1/3 power. 2 to the 4th root is the same as saying 2 to the 1/4 power. So now let's look at some problems here. Example problems. 35.3, that is a very oddly shaped 4, but it says 4 to the negative 1/2 power. Well, if we have a negative in the exponent, we always remember that that means to switch or flip the number from the numerator to denominator or vice versa. So this would become 1 over 4 to the positive 1/2 power. Now, like we said, something to the 1/2 power is the same as just giving it a square root. So this is like saying 1 over square root of 4. 1 over square root of 4 is 2. So your answer is 1 over 2. And that's how you do these. These are going to be a little simpler to get it started. So 1 over 2. Next one is negative 27 to the negative 1/3 power. Start by flipping it because we have a negative. This negative does not affect the numerator denominator. The exponent one does. So therefore, we say negative 1 over 27 to the 1/3 power. And 1/3 means cube rooted. I know there's 2's, but cube rooted. So we say negative 1 over cube root of 27. I don't know if you know your cube roots, but cube root of 27, that's the same as saying, well, cube root of 27 is 3. Remember, cube root is saying 3 times 3 times 3. It's 3 cubed. 3 times 3, 9 times 3, 27. So 3 cubed would be the opposite of cube root of 27. And that's how you plug those in. Now I'll say this, you could actually use your calculator. I'm going to try to show you as best as I can from this angle. But if I was doing example 35.4, look back at this right here. Let's go back there. I'm going to type that into my calculator. So I type in negative, move it up, negative 27. Then you have to do the little caret sign here. Caret. I'm going to go ahead and put it in parentheses. I don't know if you have to or not. Negative 1 divided by 3, close parentheses, enter. Now it gave me this decimal, negative 0. So you can see it better. Negative 0.3 repeating. That is true, but if I want to switch that to a fraction, I can say math. This, and hopefully it's bright enough, but number 1 says fraction. I can push enter. Now it says you want your answer in fraction form. I do, so I push enter again, and it gives me negative 1 over 3. So you can also actually put these in your calculator. That's probably what everyone will do. I need that TI-84 plus though. A couple more that add a little something to it. 35.5 gives us 16 to the power of 3 over 2. Well, what you have to do to solve, say you were solving this without a calculator, you would have to turn that into open parentheses, 16 to the 1/2 power cubed, or you could say 16 cubed to the 1/2 power. You can do either, because if you remember the power rule, this is the same thing when you would multiply those. That would be 16 to the 3/2 power for both of them. But we just broke it down the opposite way. We kind of factored it out. Once you get to this point, like this one is saying, I'll work both of them out. This one says 16 to the 1/2 power. 1/2 power means square root. So I write it like so. Square root of 16 is 4. Then 4 cubed is 4 times 4 is 16 times 4, 64. Now both of these will be the same answer. If I cube 16, that would be 16, that would be 4,096 to the 1/2 power. And then I can type in square root of 4096 and get 64. Okay, so you can do it that way. Or, once again, you could type that in your calculator. you could say 16 to the power of parentheses 3 divided by 2, you get 64. 35.6, let's solve this one by just plugging it into our calculator, because I'm sure that's what y'all would prefer. It's negative 8, get my finger pointed the right way in the camera, negative 8 to the negative 2/3 power. So I punch negative 8 caret parentheses negative 2 divided by 3 close parentheses, and I get negative 0.25. You can probably figure out that that's negative 1/4, but I'll punch in math. 1 is fraction, so I push enter. You want your answer in fraction form? Yes. It gives us negative 1/4. So that would be your answer. That's how you punch it in the calculator. And that is how you do all those different concepts. A lot of concepts in this lesson. But yep, there's a fractional exponents.